He worked as a trainee in Think Business Networks for 1 year, as a J2EE designer in Kinsan Incorporation for 3.5 years, as a senior software engineer in Think Business Networks Private Limited for 3.5 years, as an integration specialist in Nostrom and SCE for 1 year, as a senior technical specialist in Infosys Technology Limited for 2.5 years, as an integration architect in Syngenta for 2 years, and as a BPM EAA architect in BP for 2 years, as a SOA architect in O2 UK for 6 months, and as a solution architect in Colt Telecom, ING, ABN Amro Bank, RBS Global Banking and Markets, Royal Bank of Scotland over 6 years. As a senior technical architect in Infosys, Diageo, HSBC Commercial Banking, Tata Consultancy Services, Marks and Spencer over 16 years. And he has over 25 years of experience, and he is uh, currently working as a senior principal enterprise architect Infosys London over 5 years. Also, he is a mentor for our local online for women UK. His top skills includes SOA, enterprise architecture, and EAI. And his certifications include TOGAF 9.0, IBM Certified BPM Application Developer 8.5.6, AWS Certified Solution Architect. I welcome you, sir. I am sure that this interaction with him will be a valuable learning experience for all of us. I welcome you again, sir. Session is over to you, sir.
Thank you, Satya.
Thank
Firstly, everyone, great to be here. It's always a pleasure to talk to the academia. Just one thing I wanted to make you all aware is that, see, my focus is going to be mainly how we use technology for practical applications, right? So I'm not so much focused on what is the latest design or algorithms or the devices or tools and so on. But look, there's a transformative power of this technology. How do we take those technology and put it to the real use within enterprises? So I'm going to be mainly focused on that. So I think this is going to be very invaluable, because often the gap between what we learn and the development of the educational side of things itself probably is much wider than what gets implemented within enterprise. Enterprise is meant for scale, engineering excellence, and so on. So I think this gives a different perspective to perhaps the sessions you may have had before. That's number one. Number two, a lot of the work that we are doing, especially when it comes to AI, many do tend to ask this question. Look, how do we if this technology is so transformative, so how do we envisage the new world, which we cannot foresee now? So the way to look at it is the things that we have created today in enterprises or anywhere is created based on how humans are able to solve complexities. If you are able to solve complexity, let's take an example of a university or a college. You probably have many departments, and many departments has different roles and responsibilities and so on. And the reason for that is that that is how humans solve complexity. But you need to ask now, hey, look, if I have a new world, if I have in the new world, I could have, let us say, AI or other new, more powerful tech comes, is my structure that I have, today is correct? What is the future world is going to look like? So I want to give a bit of a glimpse of that. I'm not going to be able to go into the details of the solutions or what is the architecture and etc. But I hope that this is one of the tough questions we try to answer, say, beyond what what we can see today. What are the utilities of this new technology? So from that. From that, I've picked 4 topics to say, look, what maybe the world look like maybe 5 or 10 years from now, and perceptive to that. So I won't show you perhaps a implementation of it or something that is working, but it is more of the concepts that we are thinking. Again, there is a reason for that. Is most of you probably are hearing often that, look, with AI, a lot of the jobs are going to go. And what I am doing today is perhaps AI will be able to do in much shorter span of time, and so on. But one of the questions that we are not asking as much is that, okay, I've got a really massive power coming to my hand, and what can I do differently with that power? And that is very important for us to grow. To give a simple example of what it might look like, my own experience of my grandfather. He had a small business. I think it must be the early 1930s or something like that. We hear this story all the time. So he could only sell what he made within a range of 5 kilometers, because he had to use the bull cart, and that has a range only 5 to 10 kilometers a day. So he has to go every day to the markets nearer to the village, and he has to sell his product, and then or he drops the supply to the various stores, and one day, the next day, he goes, collects the money, drop the next supply, etc., etc. So his maneuverability was only 5 kilometers, and they only had horse cart or bullock cart and so on. But when the bus came, the range suddenly became 20 kilometer a day, or twice or thrice more. And when the trains came, it became even more. He could sell his products 50 kilometers or 100 kilometers away, and so on. So with the technology, the reach becomes far greater, right? And that is one of the things to keep in mind, because often, I think, as our human race, we are very, very ambitious people. When you are selling to a small to a network of nearby villages, and you suddenly look at the possibility, look, I can sell it a little bit further, I can go to the town, and then you're saying, okay, I can probably sell it at the state level. And when your reach becomes even larger, you say, okay, I can do this as a national business or an international business, and we keep growing and going, and ambitions never stops. So that is very important, I think, a human element to that, because we when we have the power to do, we always want to do more. We never want to do less. We're not going to be satisfied and say, hey, look, now I've got AI to do my job, so I'm not going to do anything. That's not going to be the case. But I've got AI to do, and therefore, what more can we do? Okay, so I just want to give a glimpse of a few examples, how product design in the new world might look like, immersive learning and workforce training experiences, and software engineers. What sort of a new world of software engineering that might be, and augmented store analysis. There are many such stories I can tell you, but let me start. It's a very simple model of a boat. So if you look at the evolution of how these, the ocean transportation took shape, the earlier inventions are like the sailboat. So you had the sails work based on the wind, right? So if there is wind, the sails could move, and of course they maneuver the sail in a way that they can direct the boat. And then perhaps one of the innovation was, look, let's do the paddling. So Some of the interesting work in old days had been, they had a lot of people paddling the boat. So 20 on one side, 20 on the other side. So 40 people are paddling the boat. They could go anywhere without the dependency on the wind, right? That was probably the first innovation. But that has its own issues, of course. The scale and how many people could be transported, and the purpose of that such transportation was limited, and so on. But when the steam engine came, which is transformative technology, perhaps just like the way we look at AI today, it changed everything. Everything that was done manual became mechanized or automated, right? The first invention of the design of the boat was something like this. You still have the paddles. You see the 3 paddles or 6 paddles on each side. And then instead of human, they took the human out, and then they put the machine to do the job. So what the machine was doing, of course, the steam engine, or I think in this example it's looking like a battery operated, but the earliest design is you took the human out and then you put the machine in there. And when it comes to AI, that's how we are thinking at the moment. We're thinking, hey, look, I've got a bunch of people doing some work. So now we've got the AI. I'm going to take the AI. I'm going to take the people out and then put the put an AI there, and therefore I don't need the people to do that job. Let us say, if you take this example of a boat, probably there were 40 people, at perhaps the largest boat back in those days, in the 12th century, perhaps, or 12th to 14th century, had 40 people driving this, operating this boat, and the maximum maybe 100 or so. From there is our new world. The new world no longer looks the same as the old. You don't have the paddles, you have propellers, and you have far more powerful propellers. And this can transport maybe 5,000 people, and maybe 10,000 times more weight, and so on. And this one employs probably 1,000 crew members, 10 times more people than what was possible in that old system. So I'm just setting an expectation. The way we are seeing the enterprise as uses this technology is not to cut down the jobs or let things go off, but we're going to be dealing with something far more in scale, far more in features, and so on and on. So now we can go into seeing, look, how this particular aspects, AR or VR, could augment that new world. What role could it play? We don't fully know everything, of course. This is, every organization, every team, every, perhaps a specialist out there, or the engineers out there are thinking, look, this amazing technology that's been created in the academia, how do I put that in use, and therefore I can build something far greater than what we have today? Most of our time goes in perhaps debating and discussing what those killer use cases are, and how do we go take the current world, which looks like the steamboat, to this new world, which is the cruise liner, right? So my first one is this. So today, if you go into any of the online stores, okay, Flipkart or Amazon or any of this, how do they get this sort of product listed on their website? So traditionally, they need to, of course, whenever they are releasing a new line of clothes, for example, maybe there's the festival coming up, Diwali, and they have the new set of clothes being released. They need to firstly hire some of the models and then put those apparels on them, and then they take the photos of it, photos of them, and that goes into their website. And then you probably would have browsed it so many times to see, okay, this is what I'm buying, and so on, and you're able to see it on a perfect model, whatever their dimensions are. But you may also have, look, that's not enough for me. That's not enough for me to know that this is going to be great for me, right? So then these retail stores would have come up with various other features. You would have seen, okay, rotate 360 degrees so that you can see 360 degrees, and you can zoom in and out, and different features. They are very much static. They are not a very complex operations. But imagine, the next stage of that was, but this exercise is very time consuming, as well as very expensive, because you need to arrange a photo shoot. It might take 4 hours for one session, and you can only do on a certain clothing line. And if you have to cater to diversity, gender, you need to have different genders to take the photos. Skin tones, so you have to find different skin shades to be able to give that appearances, etc. So that's a time consuming and cost effective work. So what they did was, with the ML machine learning algorithms, they could take a photo. I think you would have seen this in so many other probably YouTube shorts and so on. You could take a sort of neutral background, like a green background or something like that, and then render the clouds on top of the models, which is already there. So if you want to see different colors of the same model, they automatically render it, right? So that's been the past. But now what we are looking at is, look, that still is not representative of how would it look on you, right? So what if you are able to upload your photo to the website, and see that cloth appearing on you, right? So which there's an area where you start to look at generative AI, right? How do I use generative AI, which can take my photo and render these new things on me? So which means, whether it's your skin tone or whether it's your dimensions, it's more realistic to that. But we're not stopping there, right? We are going one step further to say, hey, look, what if I upload my photo, but look, I'm buying this clothes because I'm going on a holiday to Switzerland. I want to see how would it look on me when I am in, let's say, Switzerland. I want to create an imagination of it. I want to see that on a video. So I want to see myself, let's say, walking by the Alps, skiing, whatever it is, and I want to be seeing myself in that particular apparel, which is probably never possible before. We never imagine a boutique shop, a local business who has created a clothing line, and for the local community, and they needed to do something like this. They needed to provide a feature in which someone will be able to come in, upload a photo, and then say, choose Switzerland as my destination. I want to see myself walking there. That would have costed them a lot of money. They would have lost, and it was never done because of the tediousness and the expense of it. But with the new sort of and the tech in the world where we are, we can imagine that is being possible. So imagining that you can upload your photo and you can generate a video, and you're wearing this new clothing line that you are interested to buy, and you can see yourself in it, right? And this is an example of a new world that we can envisage. So it's becoming far more sort of a hyper personalized. You are able to not only see the static way of seeing things, but moving into a new dimension where the immersive experience becomes even more stronger. Right. I'm going to go through the different scenarios. The second one, I suppose, which is probably all of you are familiar with, and something very, very important from the enterprise perspective, because we need to continuously make our workforce equipped with the latest things. So today, you are all in the universities teaching children, and you have a very interesting pattern that you would have always seen. Probably 20% of your classroom excels. They are outstanding performers. They're very studious. They score very high marks. And there's probably another 60% of the students, probably above average, multi-skilled. They enjoy the sports. They enjoy the movies. They do their studies as well. And then there are certain percentage of students who may not perform as much as they should. And you think it's their problem. You think these students are not probably intelligent, not disciplined, but you don't really question the mode of education, whether that is suitable for them or not. What is the mode of education today? Okay, you go into the classroom, you teach the students, and they have to go back to their hostel or home, take a book and go through that over and over again. Okay, that is the only mode of study that is available today. Okay, and we don't question that. We somehow assume that, look, if you cannot read the book and clear the exams with high percentage, then you're not good enough. I think that is a very wrong understanding of how we should teach, right? Each of us has different needs. Some may be enjoying reading books. Some may be enjoy listening to knowledge or experience, or they learn by listening. Some may learn by watching. They are visually more perceptive. But some may require different ways of learning. I want to get a feel of how this is all happened, rather than I'm able to imagine that, which is not what we offer today. Okay. And now with the AI, we have an amazing possibility of turning that around and to say, hey, look, if all my students are not scoring 99%, or I'm just giving an example, okay, let us say 95%, it's not their problem. It's the mode of education which is a problem. So I want to invent better mode of educating them, and therefore they can excel. So some may be excelling by, or some may be able to score 95% by reading a book. Some may need a audio or a way of listening and watching to learn and score 95%. Some may want to learn Einstein's relativity theory by writing a song. Why not, right? Someone want to learn by debating about it. There are children who cannot stop talking, and they want to have a debate of everything, and that is the way they will learn, right? Or somebody is very interested in elaborate description of something. Someone is quite the opposite, who want to learn by keeping very short information, like Twitter. I want to learn everything in 30 seconds, and I don't want to learn beyond that. In today's world, you don't have the facility to meet that demand, meet that need. A lecturer, a professor, or a teacher cannot do everything. The teacher cannot sing and dance, because that is a suitable mode of learning for 10 of the classroom, 10 children in the classroom. They can't do that. They can't create a visual impression. They cannot have a debate. That's too time consuming and too difficult, and so on. But with the AI, I think that is possible. So one of the things that we're looking at is, if I have an enterprise and I have got hundreds of thousands of people, and we need to keep them continuously upgraded to the latest tech that are happening around us. And not only the tech, the operating procedures, how to remediate when there are issues. And there are many needs that requires people to continuously learn. So with the AI, what we are trying to do is to firstly create an abstract content. Means you have got all the facts that you want your people to know. The mode of delivery itself, so I've got all these facts. Here's my theorem, here is my algorithm. But how I teach that to the students can be delivered through maybe 10 different ways. Okay, not just one way. You're not going into the classroom and just repeating yourself and asking them to read it. That's just one way of doing it, but you are offering 10 different ways. Like I said, okay, you have a content. Imagine a student could go into a website where they can say, hey, look, I want to learn about a sorting algorithm, and I want to learn it in my own way. So write a song. Why not? Or create me a 2-minute sort of a video to teach me how to do the bubble sort or one of those algorithms, right? Or I want to have a debate. So I want to ask back and forth. That's the best way for me to learn. So we're sort of creating that a layer in which the mode of education could completely transformative, right? So this is something that we've never imagined before. Now with this tech, look, we are able to go beyond. So the 10 may become 20, and it is another element of hyper personalization. It really delivers to your own needs. And well, this is a picture that simply got created by one of these tool, but it shows the diversity. In one hand, it tells you, look, I can use a VR headset to, immerse myself in a battlefield, Mahabharata battlefield, and then I will learn how or what happened in that, because I am able to visualize it. We all struggle. I struggled a great deal when I learned history. And all those years that I had to memorize was such a difficult thing. And when you are learning it in a different way, you perhaps are able to do that much more efficiently. So, it's quite evident. So at the moment, for example, if you have to train someone on a heavy or high-stake machinery, giving them a sort of 3D model of that and giving them a sort of a VR headset to experience that is becoming common, right? The content generation part itself could be from generative AI. The mode of delivery, you have all these headsets and all that, they are already there, right? Just if there is any questions, maybe I can take a little pause. Right, I want to touch on something I think very important for many of us, which is software engineering. This has happened before. I think in the 1960s, if you are a mathematician, you're on a high demand because complex mathematical calculation was not possible for everybody, and there are only few people who understood maths very well. So mathematicians were one of the highly paid professions. But when the computers were invented, the computers could do probably 20,000 times, 50,000 times. I think that recent, if you have watched this news, the personal supercomputer, we never heard about like personal computer we heard, but personal supercomputer could perform 70 trillion operations in a second. So it's pretty much like, by the time you say you answered what is 2 + 2, that computer can do 70 trillion operations. So it has gone so efficiently. So what was required special skills for an individual no longer required because computers can do 70 trillion times faster. And that sort of a transformation comes for engineering also. So today, software engineering looks very complex. If you look at this code, not many people might get even, oh my God, I don't want to try this. It's going to take a lot of time for them to understand what this is doing, and all that. And enterprise systems do tend to have far more than what you see here, right? Some of the applications we deal with have 5 million lines of code, 10 million lines of code, and so many of them. So now if you have to write 5 million lines of code, It's going to take a long time. And if you want to understand what this 5 million lines of code is doing, it's going to take even more long time because it's someone else has written. Many times, for those of you who are very close to programming, would appreciate that anything that is written as a code is not just code. It's a history. It reflects many things. It reflects the mood of the developer at that point in time. Reflects sometimes the politics in an organization, because you couldn't do certain things because some other team wanted to do that. It could reflect, let us say, the lack of funding, for a certain number of years. They one of the important developer left the organization, etc. All this actually reflects in code. You would see pretty much a history sitting in the code, and it's very difficult to understand. So someone needing to go through all these things themselves and then come up with a really a productive output, it's going to be very, very difficult. Imagine this, right? You're buying a house, right? And my slides are not loading. No, okay. Something went wrong with my slides, but okay, I have to now create an imagination without a slide, right? So imagine you're buying a house. The best way I think you would do that is by going to the going to the site and having a viewing of the house you're buying. Okay, so imagine you are at the site. It's a built house by a very good developer, great looking. From the point you are opening the gates 10 meters away from the house, you understand what you're doing very, very quickly. You're assessing the dimensions, you're assessing the aesthetics, the front garden where you're going to park your car, and the doors, the bell, the calling bells, and you're opening the door. You may be thinking about the security systems, and entry into your corridor, the rooms, the size of the rooms, the ceiling, and where you have your tables, and where you even have your flower vase. You very quickly process that. Think about the human brain power. You're very, very quickly process all of them, and then you start to think about how do you make that house a home where I'm going to put the sofa here. This is where my dad is going to be sitting, and this is where my children are going to be playing. I'm going to put a little slide for them to swing around, etc. You're starting to think about what you want to do next. Very interestingly, if I gave you, let us say, a 300-page document, okay, instead of you going into that house and viewing it yourself, a 300-page document which tells you everything about that house. It says the size of the gate, the thickness, so 1 meter high and 4 meter long and 30 millimeter thick iron gate with that level of details. Okay, so the positioning of the table, the thickness of the wood, everything is in that level of detail. So you have got 300-page document. Now, if you read the 300-page document, would you get the understanding of the house as much as if you had gone to a site visit? In a site visit, probably walking to that house, probably spend about an hour. You understand everything you needed to understand, because not everything is equally important. There may be things that you barely even notice. There's a little decoration in the corner of that wall, but you don't notice. It's a nice for you. It's not important. You probably are noticing the thickness of the wall and the brick they used and the quality of the material, which is more important for you than everything else. But if it was a 300-page manual you had, then everything looks equally important. You have to read. You have to go through one by one, ignore something, get a mental picture of what that actually is telling you, and so on. And now, how many days would it take for you to understand a 300-page description of a house? Probably some days to really get to the hang of what exactly is going to look like. And assume that you've never seen that house, and you need to now buy that house. You will feel so uncomfortable. And that is actually the situation for many of the software engineers, because the code is very much the 300-page document that you get, right? And we somehow, again, expect them to understand this and, and build the imagination of how the house is going to look like. And we think that that is what is supposed to be done, right? And but what if we are able to give a sort of a latent space, a virtual reality of how this code might look like, just like the way if you had gone to view the house, how would you process them, right? So it means you want to understand what this code does, what are the functionalities. Let us say it is making an order, placing an order, making a payment, and this is how it's making a payment. In whichever way it is easier for you to understand, whether that means you want to just drill down into the latent space, and they are all like the floating bubbles that you can catch and look into it, and things like that, right? And then you want to look different contextual, or analyze the code through certain specific aspects. Like, I want to see all the top performing functions. I want to see all the poor performing functions. I want to see my code, which of my code is consuming more carbon, which of my code is more green. We never did that before. We couldn't. We don't go through that. We only go through code like it is a manual. We spend a lot of time. Sometimes some of these large applications may take 6 months to 12 months for one person to have a reasonable grasp of what's going on. But if you're creating a latent space for the engineers to understand what's going on, I think it becomes far more efficient. Again, comes down to, look, we as a human, are able to process things much more from creating sort of an augmented experience, or a new reality, right? So in this example, basically, if you're walking into the code, just like you would walk into a house for viewing, what are the things that you would see, and how would that appear, and what are the things that are important for you, and how do you reach that very, very quickly? So this is another area of very interesting work that some of them are quite advanced, proprietary, and innovative research and so on. But this is another area of focus. Many of them looking to create sort of a virtual experience for engineers, and therefore they are able to do this job much more efficiently. Right. And there are so many other utilities as well, as you could see. So perhaps in another example, I think I may have lost some slides, but okay. So another example of augmented or this AR, from my perspective, a store, a large store, a supermarket is, you've got so many aisles, entrances, and products are being sold, etc. Now we do have a lot of cameras, so the cameras records people's movement, how much time they are spending, and so on. We're doing quite a few interesting video analysis work, in which an example here would be like you're looking at how many people are going through something. That may be one perspective. So people are walking through this space more than the other space. So ideally, you want all of them to go through your supermarket equally. Not just ignore one area and just go get something very quickly and run away. Or you want to see which of the products that I have stacked has more interest. So where are the people standing more time? Are they standing because they are interested? Are they standing because they have a problem accessing that product? Right. So that becomes another interesting element. So when you start to do the video analysis, and then you can work out, a number of different things to see how you can perceive the efficiency of that store arrangement. Is one example of, look, I have I have a large sort of area, and I want to see how many people are going, how much time they are spending, and now I have hazard deduction. So if something fell off and people suddenly taking a detour, or you need to address hazards are, of course, safety risk. Someone elderly could slip and fall, and the store has to admit them into the hospital. That's a legal procedure. So how do I detect my um, hazard? Something fell off, maybe a bottle fell down on the floor, broke, and you've got all the glass pieces everywhere. So how do I detect that automatically? And how do I detect my shelf being empty? Right. So you have all these cameras. Perhaps today's world, or partly yesterday's world, where there's so many people needing to go through and keep an eye on all the products that are fast moving, the refill that, and it's a constant monitoring as well as then refilling is at work. But now with this tech, we are sadly able to perform a lot of this video analysis to be able to, like I said, detect the footfall, which helps you to rearrange your store to make the footfall equally across all the different aisles. Or you want to know where the people are spending the time on. That's another aspect of it. Or the um, hazard detection, or if the shelves are empty, how do I detect that? Even fraud detections. If someone seems to be stealing things, how do you use technology to identify the pattern that might tell that this person is doing something naughty, right? And again, these things has made a lot more easier. One of the key things about, I think, the generative AI is that it has democratized some of these capabilities that some companies used to have, of course, but they may have invested heavily in building them. But these technologies are now made available to even small businesses and shop friends, much at a fraction of a cost. So there's another example of um, the use of the technology from the enterprise context. Well, pretty much. So my interest was to take you through the practical application of these technologies. So these are the examples I thought might be relevant, interesting. I want to take any questions if you all have. If there aren't any more questions, I think pretty much that's what I wanted to cover. Back to you, Sujata or Uma. Okay, looks like probably they are occupied, but that's what I wanted to cover, folks. So unless you have any other questions, thank you very much for joining.
Participants, if you have any queries, you can ask now. Kindly put the queries in chat box.
Which machine learning algorithms used? See, we are talking about generative AI, right? More specifically. And most of the large LLMs are now supporting multimodal. So you're able to process analysis, videos, summarize them, and identify specific segments of it. Perform pattern analysis, and you can do all that. Or you can generate images. You have even more newer things like the many of the functions that we have, I think, maybe a bit of a research topic, like generative interfaces, where you are able to generate interfaces on the fly. You have generative functions where you dynamically let the machines write functions and so on. So the LLMs that we have today are the one that we use, OpenAI, for example, or Claude, or Gemini, and so on. So that's the foundation. So we're not training new models. We are using some of these models which are pre-trained to perform these functions. There was another question about generative process in healthcare. So I wanted to cover from the enterprise point of view, how this is. And from the healthcare, obviously, my visibility is, the healthcare domain that we work with. There are pharmacy companies we work with in terms of drug discovery, drug modeling, patient modeling. If you want to perform a particular procedure, could you do that by creating a sort of a simulation of it, and so on and on. Like so. Again, keep in mind, I'm not talking from the science perspective, more from enterprise perspective. So enterprise are like the large scale businesses who employ these technologies in specific areas. So of course, we deal with healthcare companies, pharmacies, and so on, and we predominantly 3D modelings and simulations are some of the focus areas. But that's how far it goes for us. Is there any storage issue? Well, I suppose the LLMs are now unblocking some of the concerns we probably have had before in terms of the token size, now, we might very soon reach a unlimited token usage. Now I think what we have nearly 1 million token that's possible with Gemini or Claude and so on. We do run into such challenges that might require higher utilization tiers, which is more expensive and so on. But we do tend to optimize. Like I said, 1 million line of code would have costed us some $1,000, $2,000, and so on. So that's how expensive it was actually to get. But of course, the engineering itself is much more expensive than that. So in the relative terms, I think that the more you pay, the more storage or the higher utilization you get. What are the issues? Well, often the accuracy is still a massive problem. Of course, you all probably would be familiar about the responsible AI, where we want to have a bias prevention. So if you give too much freedom for the system to come up with something, it comes up with a answer based on its statistics it's hold. The statistics may point to a certain demography more than the other. So there is bias. There is certainly, if you word your prompts in a manner that it can be very selective about segment which is harmful, for example. So we are very conscious of that. We don't want the system to perform an action which let us say a high stake operation which is going to have an impact for a human. Maybe you are buying something and you don't want it to automatically buy, right? That is number one in terms of the responsible usages of it. And from the accuracy perspective, of course, to be able to perform something in a high accurate manner, we do always encounter issues because the correlation wasn't appropriate for us. We have large data set and we didn't expect unrelated information could be correlated, but the system does it for you because it has got access to that wider pool. The other thing that I think the machines suffer is the human intuition. The human intuition is a very interesting problem. For example, if you are let us say you go to a restaurant and you somehow enjoy the food. The second day you go and somehow you don't enjoy the same food, despite maybe the criteria remain the same, or how you look at it. And that comes from suddenly a unsaid a priority or weightage that you give maybe to the ambience or maybe to your mood or something that has an impact. The human intuition is another element, which is the LLMs do tend to treat everything as facts, equally important. But you don't, like I said in the in the latent code example, if you're visiting a house, maybe you ignore 90% of the things that are in the house, the paint, the little switch or the color of the switch or things like that. You probably ignore 90% of it, and 10% of things are more important for you. But that's not the case for the LLMs. So you may not get results. Even that picture, I think, which I showed you, where you have the new ways of learning. It shows about some cosmic and Einstein's theory. None of probably 60% of them is not important. You don't even want to see them. But guess what? The LLMs create that, thinking that it's important for you. So accuracy, human intuition, and responsible AI, these are some of the challenges we see from the enterprise perspective. How AR, VR is using digital twin. That's an interesting one. Well, I think you may have a lot of application in the medical, I think, where we are talking about, you're creating a twin on which you can perform certain functions as a simulation. So you create an ecosystem or an environment which resonates to the actual environment, and then run your simulations into it to be able to, sort of reduce the impact of when that being done actually on. For example, if it's a patient, and you don't want to perform a particular operation or something, or you want to just trial that out beforehand to be able to know how this is going to look like. Imagine if you are able to create your version exactly like the way you are, a imaginary thing. So if your heart is 2 centimeters away from rest of the people, imagine that is still captured, and it's I think that would be an interesting one. I've not directly worked on such things in my responsibilities, but this is another area. We have digital twin in many of the functions, like in an oil company where you have to go to an oil rig and perform certain safety procedures. How would it look like? You could create some simulations to be able to do that. In the VR world, we are creating just by using gaming assets only, but what is the possibility of making our own asset of the real world? So I think, like I said, these are fast evolving field. I think that's exactly the right, I think, great questions, because that is how we might be able to develop that future world, right? So like I said, I could perform a surgery on a as a learning, right? I can do maybe a oil rig safety procedure by simulating how it looks like. But the important thing is that it needs to look exactly like it should in the real world. Maybe for an oil rig it's easier, but for a human body, let us say someone want to perform a surgery on you, and wouldn't it be nice if they have a digital copy of exactly how you look, how you are? Like I said, if your heart is 2 centimeters away from the rest of the people, and that's how your digital twin should also appear. And therefore, when someone performs a procedure, they already know what they need to do. And is it there? Probably not. Is it something that should be created? I think yes. Dr. Pierce, maybe that's your area of research. Perhaps something might come up, and at the far end of it is enterprise implementers. We might have that as well. But I think that is in some areas it's possible, like wind farms. So how do we estimate the lifespan of a wind farm? Maybe batteries and so on. You do have the opportunity to create what represents the real world, but not necessarily everywhere. And I think if your focus is healthcare, I think there's probably a little bit more to be done there.
So, dear participants, so do you have any questions you can ask?
I think that's pretty much it is, and really good questions. Delighted to talk to you all. And if you like to connect with me on LinkedIn, feel free to do so. And otherwise, thank you, everyone.
Thanks. Okay, sir. We'll wind up the session. After that, we'll one video is there. I'll play it. Okay. Venkateshan, sir. Venkateshan, sir.
Ma'am.
Yeah, you can give the vote of thanks.
So Karthik sir, I thank you. It's glad that you have mentioned so many points regarding your generative AI, sir. We will got more and more information about the generative AI because we don't have a simple thing in generative AI only, but you are giving learning things and also enterprises things stuff which will be used for enterprises and the industries. That will be very useful for all the participants and also us, right? Okay. Thank you for this session, sir. Thank you very much, sir.
Glad to be here. Thank you, everyone.
Thank you. Thank you.